Hey guys, I just wanted to make some videos just to help you with the homework. I'm starting to see some questions on homework, and I thought maybe if you had a video to help you, that would be useful. So anyway, I'm not going to do all the problems for you. I'm just going to show you how to get started with each section. Make sure when you're doing your homework that you read the directions, okay? So if you look at 43b, we talked about direct and inverse variation, and we mentioned that direct variation has the equation y is equal to kx, and inverse is y is equal to k divided by x. Okay, the constant of proportionality is equal to the k value, and with a direct variation, it's like the slope. So it does not change. It cannot be 0. Okay, so k cannot be equal to 0. All right. All right, so the first part of it says to tell whether the equation represents direct variation, inverse variation, or neither. Find the constant of proportionality if it represents a direct or inverse. So if it's direct or inverse, we need to find the k value. Okay, so looking at A, it's already in the form of y is equal to kx, so we know that that would be a direct variation, and our k value would be the coefficient, which is 3. Okay, looking at B, notice y is equal to 2x plus 1. We have this plus 1, so that means it's not going through the origin, and therefore it can't be a direct variation, and it's not in the form of an inverse, so this one would be neither. Okay, and now if I look at, let's skip to, I'll let you do C, D, let's do an inverse. Okay, look at F. F is in the form of y is equal to 36 divided by x, so that would be in an inverse, and our k value would be equal to 36. Okay. All right, so sometimes you're going to have to move things around a little bit, like Q, down at Q. You need to solve for y, so make sure you divide by x. So y is equal to 9 divided by x. So once you do that, you can see its inverse, okay? And your k would be equal to 9. Okay, so that's how you do the questions in the first section. Okay, then moving on to the second section, you're looking at the tables. So number 2 says, does each table represent a direct variation? If yes, write the equation. So again, I see direct variation. I think y is equal to k times x. And I prefer to solve for k, all right? So if we treat this like a literal equation, we know our k is equal to y divided by x, all right? See, all that I did was divide both sides by x. So what does that mean? It means that each of these tables would be a direct variation if I take my y, divide by my x, and always get a constant number. So let's try it. Y divided by x, so we'll do this. Y divided by x is our k equals. We get 5 divided by 1 is 5. 10 divided by 2 is 5. 15 divided by 3 is 5. 20 divided by 4 is 5. So it does look like it is a direct variation, and we know our k is going to be equal to 5. So when we write the equation, though, we always write the equation starting with y. So y is going to be equal to 5 times x. There's our direct variation. Okay, so now I'll try, and you try it for all of them. Okay, if you look at this third one, when I divide, I got 1/2, and then I've got 1/4. I'm dividing my y by my x. As soon as I get two different numbers, I know it's not going to be a direct variation. So that's going to be a no right there. Okay, so I gave you 2 of them. You can do the other 2. All right, looking at 3, we want to see if it's an inverse variation. So an inverse variation, remember, y is equal to k divided by x. All right, that means our constant is actually equal to x times y. Remember, we just multiply both sides by x. So we're, again, treating it like a literal equation. So that means if I take my x and my y and I multiply them, okay, let's write x times y, and I get the same number, 18, 8, 10 times 5 is 50. Nope, I don't even have to. So in 32. So this one's definitely not an inverse because they're all different, okay? I could have stopped after the second one. Okay, but if I multiply the second one, we've got 2 times 16, we've got 32. 4 times 8 is 32, and 1 times 32 is 32. So I know my constant is 32, and I can use that constant then and put it into the equation right here. So my y would be equal to 32 divided by x. There's my equation. Remember, your equation always starts with y equals. Okay, so that's that section. Let's look at, okay, It says set up and solve the following direct and inverse variation problems. Hint, plug in and solve for k. Okay, find an equation of variation. Y is varying directly with x. Okay, so that means y is equal to kx. All right. It says y is 9 and x is 3. So if I had my y be 9 and my x be 3, and I solve for k, all I have to do is divide and get k is equal to 3. Okay? Take your k and plug it back into the original equation. So y is equal to 3 times x. There's your equation. Number 4b says to use the above equation and find y when x is 5. All you have to do is say y is equal to 3 times 5. That would be equal to 15. Okay? You're going to do the same thing for 5a, but now we're varying inversely. So when we vary inversely, we say y is equal to k divided by x. You plug in your x in your y, and you get your k. So figure out what your k is. All right? And then when you write your equation, you write it as y is equal to whatever you get, okay, over x. Okay? And again, you follow 5b the same way. Okay, so just pay attention to if it's varying directly or inversely, and then you'll know whether to use the direct variation or the inverse variation. Okay, now the graphs should be super easy. Direct variation is a straight line going through the origin, so this one would be a direct variation, so we'll write direct here. Okay, no variation would be right here. This one would be none or no. This one right here is kind of a sad, but if you see what kind of looks like a hyperbola here, because our graphs are a little bit off, it would be an inverse. So those graphs should be super easy if you go through them. All right, hope this homework helper helped. Bye-bye.